All right, so here we are in the second semester, and we're about to embark on our kind of second half of the course, where the first half we were dealing with derivatives and the rate of change, and this semester we'll be hitting antiderivatives or integration. So today we're going to talk about what is an antiderivative or an indefinite integration. So suppose that I tell you that the derivative of some function is 3x squared. What is a possibility for f of x? And hopefully you would realize, well, f of x, in other words, if I took the derivative of something and got 3x squared, what would be that something that I took the derivative of? And you might say, well, x cubed. But somebody else might say, well, you could have x cubed plus 5, and I'd still get that derivative. And hopefully that would lead you to say, well, I could have f of x is x cubed minus 1,000. Or in other words, I could have f of x being x cubed plus any constant, because the constant of any, the derivative rather, of any constant is 0. So that's what indefinite integration is. So if I put the integral symbol and I put this thing right here and dx, what this is saying, well, first of all, this integral symbol is bookended with the dx. An integral symbol without a d something doesn't make sense. It's telling you what variable you're integrating over. Remember with derivatives, it was take the derivative of this thing with respect to that variable, so they have to tell you. Well, same thing with integration. They have to tell you what variable you're integrating over, and that's what this dx is in this case. So when you see this is a problem in and of itself, and when you see that, it's asking and it's saying that this guy right here is the derivative of somebody who, okay? And of course, you would say x cubed plus c. You have to have the plus c when you're doing indefinite integration. Now, we're not going to talk about this yet, but I'm saying the word indefinite, and you're like, okay, what does that mean? There's indefinite integration and definite. Notice definite integration right here looks the same, but there are numbers right here, 1 to 5, etc. And again, we'll talk about that later. What I want you to know is when you do definite integration, you get a number. When you do indefinite integration, you get a variable, okay? And you have to put that plus c in. And so this is also called, because notice it says antiderivatives. This question could have said, find the antiderivative of 3x squared. Or in other words, find the integral of 3x squared. I don't usually say the word antiderivative, but I have seen it typed on questions, so I want to make sure that you understand that. So this is just a basic formula, and I wanted you to see, so when I have the vocabulary, you'll know what I'm talking about. This is, of course, the integral symbol. The thing that you're taking the integral of is called the integrand. Again, that integral symbol, you have to have a dx. That's the variable, d whatever is the variable you're integrating over. What you get out is the antiderivative. And of course, this plus c is the constant of integration. So let's kind of look and see if we can work backwards and figure out some f of x's. And in doing that, we'll probably figure out some rules of integration. So if I said, hey guys, somebody has a derivative of 0, who is that? Well, you'd say 5, 15, pi. Hopefully you'd say any constant has a derivative of 0. Who would have a derivative of 1? Well, that would be x. X would have a derivative of 1. Who would have a derivative of x squared? Now you might go, well, excuse me, ahead of myself. who has a derivative of x? And you might say, well, it has to be an x squared, but let me ask you, if you take the derivative of x squared, do you get x? No, you would get 2x. So what would you have to multiply that by? Hopefully you'd say, well, I'd have to put a 1/2 there. So think about taking the derivative of this, power to the front would be 2 over 2, which is 1, and x. Perfect. So let's try the next one. What would give you a derivative of x squared? Well, you know it has to be x cubed, but there again, if you think about doing the derivative of x cubed, you'd have a 3x cubed. So to get rid of that 3, you'd have to have a 1/3, and I think you're seeing the pattern. That would have to be 1/4. So what is the power rule for integration? It's x to the n plus 1, but then you have to divide by that n plus 1. So whether you write that as like this, or some people write it as one fraction, obviously those are the same thing. And that is the power rule for integration. So what did we discover? Well, we discovered that the integral, this is just this chart kind of in rule form. The integral of any constant or 0 is any constant. The antiderivative, now this one's weird because it looks like, what are you integrating? But remember, there's really an understood 1 right here. And so this is real important. This is a real important statement. Why that dx is important? Because if the integral of 1, I would put x, of course, plus c. But let me show you, if I had the integral of dt, I wouldn't put x plus c. I would put t plus c. So that's why this letter is, oh, I'm sitting outside. There's my deer feeder, if you happen to hear that. That's why that letter is important, because you have to know what variable you're integrating over. All right, what if you have a constant? Well, that constant is, I mean, if I had 2, that's really like kx plus c, very similar to the 1, but you would just have 2 there, 2x. And then, of course, we have the power rule. So we have x to the n plus 1 over n plus 1. Or, as I say in words, I increase the power by 1 and divide by new power. And just like we've done many times with limits, because really, as we'll discover when we do definite integration, all an integral is a limit. When you have a constant, you can pull it out in front. When you have the integral of f plus g, I can take the individual integrals. So here's what I mean by that. Really what I'm doing, and I'm going to write this one out, but I normally don't, you won't do this, is this property right here says I could take 6 times the integral of x to the 4th dx. And of course, I would have 6 times. Now the integral of x to the 4th, I would do my power rule. So increase the power by 1, which would be 5, and divide by the new power is 5. Can't forget my constant of integration. And so I would just simplify that, and I would get this. Now, I usually don't write out this step because it's kind of like the derivatives. If you have a coefficient in front, you just divide that coefficient by the new power. So let's do this one kind of the fast way. And I'm just going to go down the line. I actually do the power first. So I increase the power by 1. I would divide by the new power. And I'm going to go down the line and do that. I would increase the power by 1, and I would divide by the new power. And I would increase the power by 1, which of course that's really x to the 0 there. So if I increase the power by 1, I get x to the first, dividing by the new power. Can't forget the constant of integration. And then I just simplify my coefficients. So I would have 2x to the 6th plus 5 halves x squared minus 7x plus c. I cannot forget that constant of integration. Notice I don't label anything as y equals or anything like that. It's saying who is the antiderivative of this, and you just write your answer like this. So why don't you try some on your own? Why don't you try number 1? Stop the video and try that. Okay, what you're going to do, ready? And I'm going to do this one. Again, as you go, you can kind of get fast and say, well, I'd have x to the 5th. What is 5 over 5? And that's just 1. If you need to write a second step or, and make it a 2-step problem, that's fine. But as you get better and just experience, you'll probably just do it in one big shebang. Increase the power by 1 would be 4. 8 divided by 4 is 2, plus x to the 3rd. I would do 9 divided by 3, so that would be 3. X squared divided by 2, that would be a 1, so I'm not going to bother writing the 1. And then finally, plus 3x plus c, and there is my antiderivative. Remember, excuse me, remember I really don't have to guess if I'm correct, because if I took the derivative of this thing, do I get my question? So in other words, if I did the derivative of this with respect to x, notice I'd go power to the front, decrease the power by 1. Power to the front, decrease the power by 1. And if I went down the line, notice that I would get this, and they match up. So I know I have the right antiderivative. Now, of course, they get a little harder, and just like when we were doing derivatives, I'm just going to clean this up. Sometimes we might have a step where we have to rewrite, and so when we have a quotient, again with integrals, it is not the integral of the top over the integral of the bottom, so I have to do a rewriting step. So let me rewrite example 2. I'm going to look at that as the integral of 14x to the negative 2. So I've just rewritten. Now I've done that. So I can do the power rule, increase the power by 1. Now be careful, when I increase, remember the formula is plus 1. So that would be x to the negative 1, divide by the new power, so that would be 14 over negative 1, which is negative 14, plus c. And as we've talked about, they're not going to leave, probably in the multiple choice answers, the negative exponents. So I would write that as negative 14 over x plus c. And this is my antiderivative, or my integral. Let's see if you can rewrite examples. I'll give you a hint. You're going to have to rewrite examples 3 and 4. And then do the integration rules. So stop the video and see what you think. All right, example 3, here I go. That would be the integral of x to the 1/2 power plus, the 1/2 doesn't go anywhere, and that would be x to the negative 1/2 power dx. Now remember, I'm doing these separately. I don't write them out separately. I don't take the time to do that, but I'm thinking about, I'm doing each one separately. So if I increase the power by 1 of x to the 1/2, that would be x to the 3/2. Now remember, dividing by a fraction, if I say divided by 3/2, that's the same thing as multiplying by the reciprocal. So that would be 2/3 out in front. Now let's do the same thing here. I'm going to write this one out in steps. I'm going to increase the power by 1. So if I add 1 to negative 1/2, that's 1/2. Now this 1/2 came along for the ride because of this guy, but this 1/2 dividing by the new power, that's multiplying by 2, so I really have a 2 there. Can't forget the plus c. And so my final answer when I clean that up is 2/3 x to the 3/2. These 2's cancel. Again, they might write x to the 1/2 or they might write square root of x. Both are correct. Plus c, and that's my final answer. All right, let's look at number 4. As we learned from derivatives, again, I can't integrate top and integrate bottom. It doesn't work like that. When you see a quotient and you see a monomial, fancy word for one term, monomial, then you need to just divide. So again, let me rewrite what this is really saying. X cubed divided by x squared is x to the first plus 2 over x squared would be 2 over x squared, or in other words, 2x to the negative 2. So that's really what I'm integrating. Now do the power rule for integration. Increase the power by 1. So this is going to be x2 to the 1/2. This guy, increase the power by 1. That would be x to the negative 1. Divide by the new power. That would be negative 2. Can't forget the constant of integration. Notice that I'm putting that in, that constant of integration in, right after I take the integral. That's going to be important. So don't go like, oh, I know I'm going to have to rewrite this, so I'm going to just wait on the plus c and do it in my answer. No, you need to be writing the plus c right after you do the integral, and that's going to be very important. All right, example 5, last one. Remember with derivatives, there is a chain rule idea with integration. And so in the same way, I want you to look at kind of like what we talked about with derivatives. If I had this problem, could I go straight power rule on that and say the answer is increase the power by 1, divide by the new power, and do that? I actually could. And the reason being is that the derivative of this inner thing is 1. Now, if you look at this one, I can't go straight power rule because the inner derivative is not 1. So you say, well, what do we do? Well, there is a chain rule idea for integration, but we're not there yet. So that means that on this unit, if you see something before you do the power rule, really you have to make sure that the inner derivative is 1. And if you look back at all the examples that we've done, look what's being raised to the powers. Those are x's. X's, 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 x's. Everything has been 1. So when you notice what's being raised to the power is not 1, you've got to think to yourself, oh, gee golly whiz, the power rule doesn't work. So what you have in this unit, all you have to think about is, well, I could rewrite this. Rewriting is the only thing you have right now. So if I square out this, that would be 9x squared. Don't forget that middle term, 30x plus 25. So really, these two things are the same thing. And of course, in this statement, I know you know how to integrate that. Increase the power by 1, that would be x cubed. Divide by new power, so 9 divided by 3 would be 3. Increase the power by 1, which is 2. 30 divided by 2 is 15. Of course, 25 would be 25x. I put my constant of integration, and I'm done. So that is how you take the antiderivative, or how you do indefinite integration. Just remember that plus c. All right, peace out.